David Smith here with another Flip Classroom math video. A few tips before we get started. First, remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to perfect your notes, or if you want to try the problems before I explain them. Lastly, remember that you could turn on the captions and read my words going along the bottom of your screen. Okay, now we're going to start looking at series. And series is just a sum of a sequence. So we're going to do this with arithmetic sequences only today. So a series is summing up sequence. So basically it's all your understanding about sequences, but now we're going to add all the terms up and find out what that sum might be. And also, check it out, we're only doing finite sequences. So these aren't sequences that go on forever. That can be done in some cases, not in others. But we're going to do finite sequences. So these are ones that end. So in other words, there's a fixed number of terms. We might sum up the first 3 terms, the first 10 terms, something like that. Okay, so a little notation. S sub n means the sum of a sequence with n members. And so what that's really going to be is just u1, first term, plus second term, plus third term, plus dot, 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 all the way up to the nth term. So there's your notation. Sn is the sum of whatever of n members of the sequence. Okay? So let's take a look at a simple one here. Here's my sequence, 7, 11, 15, 19, 23. This is an arithmetic sequence with a common difference of 4 and a starting term of 7. Okay? So the sum of this sequence is just going to be those terms added up. So now I'm writing S5. So that means the sum of the first 5 numbers in this sequence. So that's just going to be 7 plus 11 plus 15 plus 19 plus 23 ends up to be 75. So S5 equals 75. Okay, let's do a quick problem. Now we're going to use the explicit formula or the general term formula. So here it is. UN is 3n minus 1. And our first step here, let's just find the first 3 terms. So the first term is when n is 1. So that's going to be 3 minus 1. That's going to be 2. The second term, n is going to be 2 for the second term. So that's going to be 6 minus 1 is going to be 5. And the third term is, we plug a 3 in for n. So it's 9 minus 1 would be 8. So there's the first 3 terms. So S3 is just going to be 2 plus 5 is 7 plus 8 is 15. Okay, let's look at some formulae for figuring out the sums of finite arithmetic sequences. Okay, so just remember, we're not doing geometric, we're just doing arithmetic. Okay, so here's your first formula. This would just be n over 2 times u1 plus un. Okay, so remember, n is the number of terms in your sequence, u1 is your first term, and un is your last term. So obviously from the formula, this version is really good if you know n and the first term and the nth term. So if you have those 3 pieces of information, then you can plug this formula in and you'll get the sum of the n terms in that sequence. However, sometimes you might not know that information. You might have a little bit of other things. So this one is n over 2 times twice u1 plus n minus 1 times the common difference. So this one is if you know the first term, you know the common difference, and you know how many terms are in the sequence. So one or the other of these 2 equations are going to help you find the sum of your sequence. And I know you're going to ask, why is this one so different? All we've done is we've taken the un and we've figured out, this is from 2 lessons ago, this is the general form, the explicit form for un. It's just u1 plus n minus 1 times d. So I just substituted this in for un into this equation. So that gives me 2 u1s, because I have one from here. I got another one there, so 2 u1s. And then this is just that piece there. Okay? So these are things you're going to get used to. You want to write them down on your cheat sheet. They should be pretty familiar by the time we test out on this material. Okay, let's do one of these sums. Okay, so here we go. I've got an arithmetic sequence. It's got 8 terms, and the first term, u sub 1, is 3, and u sub 8, the 8th term, is 17. Find the sum of the series. So before we jump into that, I just want to do a little bit of vocab here. This is a sequence. We've described it, number of terms, first and last term. That's a sequence. We call it a series when we're trying to find the sum. Okay, it's the same string of numbers. But if you If you're analyzing a series, it means you're focused on finding the sum. If you're analyzing a sequence, you're focused on finding terms or finding the formula, things like that. Okay, so we have two formulas that we can use. So our first step in this problem is figuring out what we have, and that will tell us which formula to use. So analyze this, take a look at your formulas, remember what we did on the last board, and think about which of those two formulas you're going to use. Okay, if you said this one, you're right. We know the number of terms, and we know the first and last term. So this is the correct formula to use to find this sum. Pause the video, see if you can do that. Okay, let's see how you did. So we're going to write S sub 8. This means the sum of the first 8 terms of this sequence. It's going to be 8 over 2. I'm just plugging in using that formula. Times the first term, 3, plus the last term, 17. Okay? So that's a correct plug-in step. Make sure you show that when you test out on this material. So let's move it on down. S8 is going to equal 4 times 20, which is going to be 80. So that's the sum of this sequence. Okay, let's do another sum. Let's find the sum of a series here. So now I'm actually showing you the terms, 1, 5, 9, 13, plus dot, 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 to a total of 30 terms. So now look at this problem and figure out which one of these two formulas is going to be the best one to use to analyze this. They both work, but one is not as good as the other. Okay, if you thought this formula is good, you're right, because we know our first term, we know our n is 30, and we know our difference, our common difference is 4. So that would be a direct plug-in. We could use that formula to figure out the sum of the series. This one could work, all right, because you just have to figure out what your 30th term is. So you can figure out the explicit formula for the sequence and then calculate the 30th term and then use this formula. But that's a much longer way to go. So let's use this one. So what we're going to write is S30 is going to equal 30 over 2. I'm just doing my plug-in. Now I'm going to use these deals. So that's going to be 2 times U1, which is 1, plus 30 minus 1, that's n minus 1, times our common difference, which is 4. Keep track of everything with your parentheses. Make sure your algebra is good. So S30 is going to be 15 times, this is 2, plus, now 30 minus 1 is 29 times 4, D8 times 2 is 116. Simplifying it on down, 30 equals 15 times 118. I need a calculator for that. So 15 times 118 is 1770. And that's your sum of the first 30 terms of this arithmetic sequence. Okay, one last sum. Okay, so here it is. Find the sum of 6 plus 10 plus 14 plus 18 plus dot, 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 all the way up to 102. So think real hard, pause the video, and figure out if you can tell which of these two formulas we can use. Okay, first off, we don't have enough information yet. I don't know how many terms are in this sequence. Both of these formulae use n. So I'm going to need to figure that out. I do know my first and my last term, so if I can figure out what n is, I could use this more simple formula. But I don't know what n is. Fortunately, we can solve that, which is why I added this formula up here. This is the nth term formula, the explicit formula for any arithmetic sequence. So using that, we know that un is 102. So we can go 102 equals u1, which we know, 6, plus n minus 1 times our difference, which is 4. So now I have one equation and one variable. I can solve that all day long. Let's subtract our 6 from both sides. So this is going to give me 96 equals, and do my distributive property, that's going to be 4n minus 4. So I'm going to add 4 to both sides, get 100 equals 4n. So now n equals 25. So now we know there's 25 terms in this arithmetic sequence. And I know my first and my last term. So now I can use this formula and find the sum of this sequence. So pause the video, do that work. Let's see how you did. Okay, doing my plug-in. S25, the sum of the 25 terms in this sequence, is going to be 25 over 2 times U1, which is 6, first term, plus the last term, which is 102. So this is a pretty simple calculation. S25 equals 25 over 2 times 108. I can cross cancel before I multiply. That becomes 1. This becomes, what do we got, 59? No, 54. So now I have 25 times 54. Let's figure out what that is. S25 is going to equal 25 times 54, 1350. And there's our sum. Now that you've finished watching the video, take a moment to jot down any questions you have so you can bring them to our next class and get some help. You can also watch the video again to perfect your understanding. If you enjoyed it, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.